Introduction. Welcome back to our channel, where today, we are going to take a closer look at one of the most captivating planets in our solar system, Saturn. Saturn is the sixth planet from the Sun and is known for its iconic rings, which have fascinated astronomers and space enthusiasts for centuries. In this video, we will explore everything you need to know about Saturn, from its formation to its physical characteristics, and what makes it unique from the other planets in our solar system. Formation of Saturn. Saturn, like the other planets in our solar system, was formed from a disk of gas and dust around the Sun over 4.6 billion years ago. The planet is composed of gas, mainly hydrogen, with some helium and trace amounts of other elements. The temperature on Saturn is -288 degrees Fahrenheit, making it one of the coldest planets in our solar system. Physical characteristics of Saturn. Saturn is the second largest planet in our solar system, with a diameter of over 74,000 miles, making it almost 10 times larger than Earth. The planet's iconic rings are composed of ice particles, dust, and small rocks that range in size from a few microns to several meters. Saturn's rings are the most extensive and brightest in the solar system, stretching out to a distance of 175,000 miles from the planet's surface. Atmosphere and weather patterns of Saturn. Saturn's atmosphere is primarily composed of hydrogen, with traces of helium and other gases. The planet's weather patterns are highly active, with winds reaching up to 1,800 km per hour, 1,100 miles per hour. Saturn's atmosphere also produces some of the most significant and active storms in our solar system, including the Great White Spot, a massive storm that appears every 30 years and can last for several months. Satellites of Saturn. Saturn has over 82 confirmed moons, with the largest being Titan, which is the second largest moon in our solar system after Jupiter's Ganymede. Titan is the only moon in the solar system with a substantial atmosphere and is covered in lakes and seas of liquid methane and ethane. Missions to Saturn. NASA has sent several missions to explore Saturn and its moons, including the Voyager 1 and 2 missions in 1980 and the Cassini-Huygens mission in 2004. The Cassini spacecraft orbited Saturn for over 13 years, sending back images and data that have expanded our understanding of the planet's physical characteristics and weather patterns. Geology and internal structure of Saturn. Saturn has a rocky core that is surrounded by a layer of liquid metallic hydrogen, which conducts electricity and creates a magnetic field around the planet. This magnetic field is approximately 578 times stronger than Earth's and is responsible for trapping particles in Saturn's radiation belts. The rings of Saturn. Saturn's rings are believed to be relatively young, possibly only 100 million years old. They are composed of ice particles and rocks that are continuously bombarded by meteoroids and debris from other space objects. The rings are divided into several sections, with the largest being the A, B, and C rings. The C ring, also known as the Crepe ring, is the thinnest and closest to Saturn, while the A and B rings are brighter and more massive. Exploring Saturn's moons. Saturn's moons offer scientists an opportunity to study the planet's geology and history. The largest of Saturn's moons, Titan, has a thick atmosphere that is believed to be similar to Earth's early atmosphere. The Cassini spacecraft discovered that Titan has a hydrological cycle that is based on methane and ethane, with methane rain and lakes covering the moon's surface. Other notable moons include Enceladus, which has active geysers that spew water vapor into space, and Mimas, which has a large crater that resembles the Death Star from the Star Wars films. The search for life on Saturn. While Saturn itself is unlikely to harbor life, its moons, particularly Titan and Enceladus, have the potential to support microbial life. Enceladus has an ocean of liquid water beneath its icy surface, while Titan has complex organic chemistry that could be a precursor to life. Future missions to Saturn and its moons, such as the Europa Clipper and Dragonfly missions, will continue to search for signs of life in our solar system. The future of Saturn exploration. There are several upcoming missions planned to explore Saturn and its moons. The Europa Clipper mission, scheduled to launch in the 2020s, we'll study the potential for life on Jupiter's moon Europa, but we'll also conduct several flybys of Europa and Ganymede. The Dragonfly mission, which is expected to launch in the 2030s, will explore the organic-rich terrain of Titan with a drone-like rotorcraft. The history of Saturn observation. Saturn has been observed since ancient times, with records of its observation dating back to the Babylonians and ancient Chinese astronomers. Galileo Galilei was the first person to observe Saturn through a telescope in 1610, but he mistook its rings for two large moons on either side of the planet. It wasn't until 1655 that Dutch astronomer Christiaan Huygens correctly identified Saturn's rings as a disk surrounding the planet. The discovery of new moons. Saturn has a vast collection of moons, and new ones are still being discovered. In 2019, scientists announced the discovery of 20 new moons orbiting Saturn, bringing the total number of confirmed moons to 82. These new moons are relatively small, ranging in size from 3 to 5 miles in diameter. The effect of Saturn's rings on its moons. Saturn's rings have a significant impact on the planet's moons, particularly the innermost moons. The gravitational pull of the rings creates waves and distortions in the moon's orbits, causing them to oscillate back and forth. Some of Saturn's moons, such as Atlas and Pan, also have a significant impact on the planet's rings, carving out gaps and shaping their structure. The exploration of Saturn's magnetosphere. Saturn's magnetic field is much larger than the planet itself, stretching out to a distance of over 10 times Saturn's radius. The Cassini spacecraft studied Saturn's magnetosphere in great detail, discovering new radiation belts, auroras, and interactions between the planet and its moons. Scientists believe that studying Saturn's magnetosphere can help us better understand the dynamics of magnetic fields in our solar system and beyond. The possibility of a ninth planet. Recent studies have suggested the possibility of a ninth planet in our solar system, located beyond the orbit of Neptune. This hypothetical planet, known as Planet 9 or Planet X, could have a mass up to 10 times that of Earth and may have been responsible for the unusual orbits of several distant objects in the Kuiper belt. Some scientists have suggested that Planet 9 could be a captured planet from another star system or a primordial black hole. Conclusion. Saturn is a captivating planet that has captured our imagination for centuries. Its rings, moons, and magnetic field make it a unique and fascinating object of study for scientists and space enthusiasts alike. As we continue to explore Saturn and its moons, we may uncover new mysteries and gain new insights into the formation and evolution of our solar system. Thank you for watching, and we hope you enjoyed learning more about Saturn today. Thank you for watching this video about Saturn. We hope you enjoyed learning about this fascinating planet and its many mysteries. From its iconic rings to its numerous moons and active weather patterns, Saturn continues to inspire scientific exploration and capture our imagination. If you want to learn more about Saturn and other topics in astronomy and space exploration, be sure to subscribe to our channel and check out our other videos. And don't forget to leave a comment below to let us know what you thought of this video and what topics you'd like us to cover next. Until next time, keep looking up at the stars and exploring the wonders of the universe.